Hello, everyone. Mr. Minnick's my name. Math is my game. And today, for this lesson in Algebra 2, what we're looking at is the basic components, the critical terminology that's requisite for a concept that's near and dear to my heart. I told my class just a minute ago that if you can factor, the rest of the school year is going to be easy. And if you can't, it's not. I wasn't lying when I said that. If you can factor, chapter 5 is just more factoring. And if your brain can work in the way that it has to be able to factor, then you'll be able to handle a lot of the math that goes beyond this. So anyway, today in this introduction to chapter 4, section 4, we'll be talking about what factors are. We'll also be talking about what multiples are. We'll also be talking about prime factorization. And last, but surely not least, and we might not even do these in that order, we'll be talking about rules of divisibility. Okay. So the first thing I'd like to start with then is the definition of what factors are. By definition, the factors of a number n, the factors of a number n, the factors of a number, oh, that's supposed to be n, not h. The factors of a number n are integer pairs whose product is the number. Whoop, didn't like that. Guess I got to change that word. Integer. Let's see if it likes that. Bueller. There we go. So, real important definition. More important than the definition is that you can find the factors of a number. But the factors of a number n are integer pairs whose product is the number. Now, an example is worth 1,000 words, right? So let's look at an example. A specific example. Suppose n is 8. That's a number. We want all the integer pairs whose product is that number. Now, sometimes in math, the language doesn't make sense. So we got to think, okay, what the heck does this word product mean? Does anybody know what operation is associated with the product? Not addition. Multiplication, or timesing, as some people like to say. So product means we're multiplying. I got skills in multiplying, and I'm losing control. Whoa. I don't know the rest of it, but anyway, multiplying. So something times something else has got to equal 8, and something else times something else has got to equal the number 8. Now, one thing you know about most numbers is they can multiply the number itself by 1, right? And you can also multiply what by what to get 8? 4 and 2, okay? So let me see if I can highlight these. Get my highlighter going. It's a Monday. So that number, and that number then. Now, it's interesting because I define that as integer pairs. I define this using this phrase, integer pairs. So one pair of integers that multiplies to be 8 is, of course, 1 and 8. And another pair is 2 and 4. Okay? So we would say then that 8's factors are the following numbers: 1 and 2 and 4 and 8. Now, I know for some of you this is like, oh my gosh, really, Mr. Minnick? I know how to do this. If you do, that's good. Because you'll be able to factor if you can do this. To factor, you have to be able to find the factors of a number. I'll say that again. To factor, you have to be able to find the factors of a number. I'll say that again. To factor, you have to be able to find the factors of a number. It might seem logical, it might seem common sense, but it's true. It's true. What's going to happen is in 3 days' time, we're going to be trying to do something like this. Factor x squared minus 18x minus 40. You're going to be asked to factor something like that. And to be able to do that, you're going to have to find factors of some number. So if you can't find factors of some number, there's really a very slim chance that you'll be able to do this. So there's another term then that we sometimes confuse, and that's the multiples. The multiples of a number n are as follows. I've probably mentioned this before, that one of the most frustrating things about being a math teacher is when people call me and ask me for help. They ask, do you tutor? Well, yes, I tutor. How much? $30 an hour, and I'm well worth it. Contractually, I can't tutor any students at the school and receive pay. If anybody comes to my room during my planning period, of course, I can help them there. But in my own private time, I do tutoring for non-Garrettsville students. And in tutoring, the number one question that comes up is, what's the difference between factors of a number and multiples of a number? A lot of people get them twisted. The multiples of a number are 1 times that number, and 2 times that number, and 3 times that number, and 4 times that number, etc., etc. Okay. You might say, well, what's the big deal? Why do we got to know this? Well, there's a lot of 3-letter acronyms that are thrown around loosely that people just assume that you understand what they mean. And you know what happens when you make assumptions, don't you? Bad things happen when you make assumptions. So if we look at the number 8 again, for instance, example, let n equal 8. Then 8's multiples would be as follows. 1 times 8, 2 times 8, 3 times 8, 4 times 8, etc. And 1 times 8 we know is 8. 2 times 8 is 16. 3 times 8, of course, is 24. 4 times 8 is 32. 5 times 8 is 40. 6 times 8 is 48. 7 times 8 is what, 56. 8 times 8 is 64. 9 times 8 is 72. Whoops, 72. And 10 times 8 is 80. And then 88. And then 96, etc. Okay. And again, you're probably thinking, dude, really, come on, I'm in high school. And you're going to teach me all this crap that my 6th grade teacher taught me? Yes. And the reason is, you probably already know it, but if you don't, you have to know it better than you know your first name. Factoring is the most critical thing to unlock advanced math. Whenever I tutor anybody in high school, I say, can you factor? Oh, what's that? And I'll show them this problem. And they say, I have no idea. Yeah, I can't do that. So, well, then you're going to have to be able to figure that out before I can help you any further. So it's real imperative, it's real important, it's critical, it's paramount that you understand the difference between the factors of a number and the multiples of a number. It's real important that you get that. Now, we have several calculators at our disposal, and some of them work well, and some of them don't. Some of them work very well, and some of them don't. So I've got this TI-83. I kind of prefer this one. This is old school. It's going way back. I don't know if it's going to cooperate today or not. Got another calculator that's trying to load simultaneously. I think they're fighting for RAM. So here's this TI Inspire. You guys know this one, you love it. And you might say, okay, TI Inspire, can you factor for me? F-A-C-T-O-R. Oh. Did you notice how the italicized letters went to not italicized? You know what that means. It's ready. It can do this. It can do this. So let's see if you could factor 8 for us, please. It says 8's 2 cubed. Did that list out the factors of 8? No. What the TI Inspire does when you ask it to factor is it does the prime factorization. That's good. Prime factorization's fine. It's nice to know, but that's not going to help us when it comes to factoring. So what the TI Inspire does then, the TI Inspire finds the prime factorization. The TI Inspire finds the prime factorization. Let's see. The TI Inspire, the TI Inspine. See if we can fix that. The TI Inspire finds the prime factorization, which is good. Nothing wrong with finding the prime factorization. That's handy to find some things, but it's not handy as far as factoring goes most of the time. So I guess while we're on this topic, we might as well look at prime factorization. Prime factorization. Prime factorization. What prime factorization is, what it involves is breaking a number down into the product of its lowest prime factors. Prime factorization involves breaking a number down into the product of its lowest prime factors. So now we know what factors are. So we should be able to do this prime factorization. Maybe. I like big numbers. I like the number 400. 400. It's a good number. So if we think about our prime numbers, because you got to know prime numbers to be able to do prime factorization, let's think about our primes. Our primes, not to be confused with Optimus Prime. Our prime numbers are going to be, what's the smallest prime number? Anybody know it? Off the top of their head? 4's not a prime number. Good try, though. It's 4's cousin. 4's other cousin, not 8. We're going the wrong way. 4's cousin of 2. Some people believe that 1's a prime number. By definition, 1's not prime. Prime numbers, by definition, are numbers greater than 1 who are only divisible by 1 in itself. That's weird for a number to be a who, but anyway. By definition, primes are numbers divisible only by 1 in themselves. So 2's prime, 3's prime, 4's not, but what, 5 is? And then what's the next prime after that? 7, and then 9's not prime because it's divisible by 3. 11, and then 13. From here, after 2, there's really not going to be no even prime numbers, right? 14's not going to be prime. There's not going to be any more even primes. 2's the only even one. 2's the only even one. What about 15? No. What about 17? 19? What about 21? Nope, not 21. What about King James? Oh, can't say that anymore. Michael Jordan. 23? 20, what's the next 20? 25? 27? 20, 29? 31? What about 33? No. What about 35? No. What about 37? I think that works. What about 39? I'm going to put a question mark by 39 and stop there. We don't know about 39. What about 51? We don't know about that one. We got 17. 51 is divisible by 17. Yeah, and we're going to talk about those divisibility rules in a minute. All right, so what we're doing with this 400 then, we're going to try to break 400 down into the product of its primes. And I like to branch off. I like to go like this. I like to go, okay, 400 is 2. 2 times what? 2 times 200. Cool. And what I like to do once I get my first prime numbers, I'm going to put it in a box. Just like that. So the 2 is prime. I can't break that down, but I'm going to break down the 200 now. 200 is 2 times something, isn't it? It's 2 times 100. Cool. Now, somebody might say, well, 100 is 4 times 25, which is 2 times 25. Well, the deal is we want to find all the smallest prime numbers when we find the prime factorization. So there's different routes you could take. What I'm telling you is you could say, well, this is 4 and 25, but then the 4 breaks down. My suggestion, every time I've always tried to find prime factorization, I like to break it down with the smallest factors first, and that way I don't have too many weird branches. So 100 is going to be what? 2 times 50. Okay, and then 50 is going to be 2 times something, 25. And then 25 isn't divisible by 2. It's not divisible by 3. It's going to be what, 5 and 5. So I put a box around that prime and a box around that prime. So what we do then is we say that 400 in its prime factors is 2 to some power. 2 to some power. I got to count how many there are. 1, 2, 3. There's 4 of those, right? So it's going to be 2 to the 4th power times what? Times 5 to the, let's see, there's 1 there, there's another 1 there, times 5 to the 2nd. Okay, times 5 to the 2nd. So my calculator ought to be able to do that. F-A-C-T-O-R, factor the number 400. There it is. And it can't. And finding prime factors is a skill that's necessary when you go to find an LC, a G, I get them twisted, a GCF. When you go to find a GCF, you'll need to be able to do this prime factorization thing. Okay. How do we feel about prime factorization? Does that concept make sense? So to be clear, the TI Inspire, when you tell it to factor something for you, it will find the prime factorization. Okay. Now, we're supposed to be talking about factors of a number. I think we did that. We're supposed to talk about multiples of a number. I think we did that. We're supposed to talk about prime factorization, and I think we did that. So there's only one thing left for today. You ready for it? A number D is divisible by another number. I need another variable other than D. What should I use? Q? I don't want to use Q. That's and there's a reason for that. Something other than Q. X? Okay, another a number D is divisible by another number x if D goes into x evenly. That means there's no remainder. A number D is divisible by another number x if D goes into x evenly. That's kind of weird. So D divided by x is going to equal Q, and Q must be a whole number. Q must be a whole number. So that's what it means for a number to be divisible by another number. We would say D is divisible by x. Now, it's kind of interesting. If you divide D by x, you get Q. Let's throw some real numbers out here at this. We talked about 51 earlier, right? 51 is divisible by 17 3 times, right? So the interesting thing is we could kind of rewrite that number. I guess we could rewrite D as the product of x and Q, couldn't we? You see what's going on there? We could kind of rewrite this 51 as 17 times 3. This is interesting. So a number D is divisible by another number x if it goes into D, if D goes into x evenly. I guess to follow that up, well, maybe we won't follow that up. Maybe we'll just leave it there. Oh, I wrote 15. Dyslexia strikes again. Thank you. Didn't even notice that. Sorry. Thanks for saying something. Good looking out. Cool. All right, well, there's all kinds of rules about being divisible. And let's look at them. Divisibility rules. This is the last thing we got to talk about today. Divisibility rules. That looks like something that somebody should write on the bathroom in the ladies' room or the boys' room with an exclamation point at the end. Divisibility rules. Wouldn't that be cool to see that? There's this one place I went to, and there actually somebody scratched into the hand paper towel dispenser. Somebody scratched something in there. It was pretty cool. It was very fitting at the place that it was what they scratched in, but I can't talk about it. So, all right, a number is divisible by 2 if. A number is divisible by 2 if. Anybody know the rule? A number is divisible by 2 if it goes into 2 evenly, or if it ends in something special, right? If it ends in what digits? An even digit. 0, 2, 4, 6, or 8, right? So a number is divisible by 2 if it's even, if it ends in 0, or 2, or 4, or 6, or 8. So the divisibility rule for 3 is weird. A number is divisible by 3 if the sum of its digits is divisible by 3. This is a weird one. A number is divisible by 3 if the sum of that number's digits is divisible by 3. So, a specific example. 1, 1, 1, 1, 1, 1. 111,111. Actually, let's make it 111,111,111. 111 divided by 3. It divided evenly. Imagine that. Because the deal is 1 plus 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 1 equals 9, which is divisible by 3 evenly. So that's divisible by 3. Another one that we've probably seen was 51. 51. 5 plus 1, well, 5 plus 5 plus 1 is 6, and 6 is divisible by 3. So 51 is divisible by 3. 51 divided by 3. Okay. How do we feel about that rule for 3? Does it make sense? Cool. Well, the next divisibility rule is for 4. A number is divisible by 4 if... There's 2 different ways you could go about this. One of our students in this class earlier mentioned something about it going in an even number of times. If 2 goes into it evenly, this works. So you could say a number is divisible by 4 if 2 divides it evenly. If 2 divides it evenly. Another way to say that, or another rule for 4, is to say if the last 2 digits, if the last 2 digits is /r divisible by 4. I put is /r because honestly, I'm pretty good at English, but I don't know if you use the word is or the word are here. Let's look at a weird number. So let's look at something like 190,576. And let's think about the number 76. Is 76 divisible by 4? Isn't that what, 8? Is it 19? So let's try this. 190,576 divisible by 4. And yes, it is. Okay, so the deal is the last 2 digits, if they're divisible by 4, then the number itself is divisible by 4. Does that make sense? All right. Cool. Well, I hope everybody remembers the rule for 5. A number is divisible by 5 if what? If the sum of its digits? Oh, there it is. If it ends in 0 or 5. So 95, 300. Anything that ends in a 0 or 5. Cool. Some of these rules piggyback off of others. A number is divisible by 6 if... Anybody know this one? It's kind of like 4 in a way. Remember when I said if it divides, a number is divisible by 4 if 2 divides it evenly? A number is divisible by 6 if 3 divides it evenly. Another way to say that is if it is divisible by both 2 and 3. So a number is going to be divisible by 6 if 2 and 3 both divide it. A number is divisible by 6 if both 2 and 3 divide it. About 5 years ago, I had a strapping young man in this class. He was my student teacher. His name was Dr. Jones. And there is a rule for 7. I don't remember. It's really complicated, more complicated than I care to explain. So for now, with 7, we're just going to say try it. Okay? But let's jump to 8. A number is divisible by 8 if 4 divides it evenly. If 4 divides it evenly. Dividing it evenly is kind of the same thing as saying it's divisible by both 2 and 4. Okay? So if you divide something by 4 and that quotient ends up being even, then 8 would have divided the thing. Okay? So let's look at 96 then. Example 96. Okay? So 96 divided by 4, 96 divided by 4 is 24. Okay? So that's 24, which is even. So because that's even, then 96 is divisible by 8. Okay, because of that, we would know that 96 is divisible by 8. Does that make sense? Okay, cool. A number is divisible by 9 if, this is just like the 3 one. Remember how 3 was? What was the rule for 3s? For 3, it was the sum of its digits is divisible by 3. So here it's going to be if the sum of its digits is divisible by 9. So earlier we looked at that one, the 1, 1, 1, 1, 1, 1, 1, 1, 1. 1 plus 1 plus 1 plus 1 plus 1 plus 1, 1, 2, 3, 4, 5, 6, 1, 1, 1. You know what? I'm going to add some more to that. I'm going to add a 108 to the end of that. So plus 1 plus 8. That's going to be it's going to be 18, and 18 is divisible by 9. So 111 billion, 111 million, 111,108 should be divisible by 9. Let's try it. 111, 111, 111, 108 divided by 9. There it is. Whoa, I forgot the O. 111, 111, 111, 108 divided by 9. There it is. Okay. There's a couple more. A number is divisible by 10 if what? If it ends in 0. If it ends in 0. If it ends in 0. So 6750. Something like that. Beyond this, you could use some of the other rules and make up your own. A number is divisible by 12 if 6 divides it evenly. A number is divisible by 14 if 7 divides it evenly. A number is divisible by 16 if 8 divides it evenly. You picking up what I'm putting down? Okay. So here's the last thing we're going to do then. We're going to do 2 more examples, and then this is it. Find the factors of these numbers. We'll do a nice easy one. We'll do 24, and we'll do a not so easy one, 288. $24 is a piece of cake, right? So when I try to find the factors, I like to start with 1. Here's just a suggestion. Start with 1 in the number. So that's my suggestion to you. Start with 1 in the number. Start with 1 and the number. Start with, whoop, this is supposed to be a 1. What the heck? Dang it. There we go. Start with 1 in the number. So when we have 24, 24 is going to be 1 and 24. What else? Then we'll go up one at a time if possible. So does 2 divide 24? How many times? So we got 2 and 12. Does 3 divide 24? 3 and 8. Now, because 2 and 3 both worked, what's that tell me another one later on is going to work? That tells me 6 is going to work, right? So 6 is going to work 4 times. Maybe I should have wrote 4 and 6 here, though. I guess that's the same thing, right? 4 and 6. Are there any other factors of 24, or is that it? That's it? Well, that's not bad, is it? Okay. Well, what about 288? Is that one going to be easy? 288. Oh, man. So it's going to be 1 and 288. 2 and 144. Does 3 go into 288? 2 plus 8 is 10. 10 plus 8 is 18. 2 plus 8 plus 8. 10 plus 8, 18. Is 18 divisible by 3? Yeah, so 3 is going to go into 288. That's 3 times 8 is 24. Whoop, 3 times 9. 3 times 9 is 27. That's 27. That's a 1. That's an 8. So what, 6? 96. So 3 and 96. Oh, man. Does 4 go into 288? Since 2 went in 144 times, 4 is going to go in half as many times as 144 is, right? So how's that going to be? 4 and 72. Do you see the way that works where you kind of... Okay. What about 5? Does 5 work? No. 6? 2 and 3 both work, so 6 has to work, doesn't it? So 6 into 288. 6 times 4 is 24. That's a 4. Bring down the 8. That's what, 48. 6 and 48. Okay. What about 7? I don't know if 7 works or not, so I'm going to have to try it. Does 7 go into 288? 7 times 4 is 28. 7 times 1 is a 7. That's 41 and 1 7, so that's not, nope, so 7 doesn't work. Okay. What about 8? 4 worked, so 8's going to work. Well, 4 worked evenly. So what's 8 going to be? 8 and half as many times as 4 did. 4 worked 72 times, so what's half of 72? 36. So 8 and 36. Is 9 going to work? 2 plus 8 was 18. 18 is divisible by 9, so 9 is going to work, isn't it? How many times does 9 go into 288? 9 times 3 is 27. Bring down to 1, there's an 8. 9 times 2, so 9 and 32. 9 and 32. I don't think 10's going to work. I know 10's not going to work. What about 11? Is 11 going to work? 11 into 288. 11 times 2 is 22. Bring down a 6. 11 times 6, that's 66 and 2. And 2, 11, so that doesn't work. What about 12? Is 12 going to work? 6 worked 48 times, so 12 is going to work 24 times. You starting to get the hang of how this works? Okay, 13. I don't know if 13 goes into 288 or not. Probably not. 13 times 1's, 13 times 2 is 26. Bring a 2, bring down an 8. 13 times 2 is 26. That's a 2. 22 and 2/13. That's not going to work. 7 didn't work, so 14 is not going to. 15. I think a number might be divisible by 15 if it's divisible by both 3 and 5. Was this divisible by 3 and 5? No, so 15 is probably not going to work. 16. Since 8 worked, 16's going to, since 8 worked evenly, since 8 worked evenly, 16's going to work half as many times as 8 did. So it's going to be 16 and what? 16 and 18. And then we're back to 18, and that's probably about it. It's a lot of factors. So this one I put up on the board earlier. Maybe you looked at it and you tried to figure it out. Maybe you looked at this and you tried to figure it out. To figure this out, you're going to have to find all of 40's factors. Did you know that? So let's say real quick, if we can't find 40's factors, what are 40's factors? 40 and 1, 2 and 20, 4 and 10, 5 and 8. Now, one of those pairs of factors is going to be the ones that we're going to end up using here. And we'll talk more about that tomorrow, and hopefully you kind of see where we're heading in the future with this. It's been real. It's been fun. I hope it's been educational. I'll see you next time.
Good.